Hi everyone, my name is Tiffany Tanggara, and today we will conduct an analysis with SmartPLS and interpret the results. For this analysis, we will use 4 variables, which includes 2 independent variables, 1 mediating variables, and 1 dependent variables. The variables that I choose are financial literacy and financial self-efficacy for independent variables, procrastination for mediating variables, and also financial well-being for my dependent variables. So the structure of this video will be first importing the data, drawing the model in SmartPLS, run the SmartPLS, and conducting the outer and inner model test, and conclude the result. So here are the step-by-steps. So first, we have to add new project and import the data to SmartPLS and make sure that your data is saved in CSV format. After importing the data, insert all of the indicators to the drawing pad, and after you move all of the indicators, rename all of the latent variables. In this case, I will rename mine to my chosen variables, which are financial literacy, financial efficacy, procrastination, and also financial well-being. Next, connect each variables, because if we don't connect the variables, then we cannot calculate the variables. Then the model will look like this. After finishing the model, we need to conduct the common function in SmartPLS, which are PLS algorithm, bootstrapping, and also blindfolding. So first, we need to click calculate and go to PLS algorithm and press start calculate. Next, go to the outer loadings and see if it is reliable or not. If the result is above 0.7 and the color is red, it means it is not reliable. It can be seen here that there are some indicators that are not reliable, so we need to go back to the model and delete some indicators that are not reliable. As we can see now that the data is already reliable. Now we need to conduct bootstrapping. First, we need to go to the model and click calculation and then click bootstrapping. In this case, we will just use the default settings. If my p-value is under 0.05, it means that the data is reliable. As seen here, that when I press outer loadings, all of my p-values are under 0.05, which means that is reliable. In order to check the Cronbach alpha, we need to go to PLS algorithm and HTMT. We need to go to construct reliability and validity. It can be seen here that the data is above 0.07, which means these data are reliable. We need to take note that the RHOA should be higher than 0.7 and the AVE should be higher than 0.5. Next, we go to the discriminant validity. This is the result of my data, which explains that the top rows are the square roots of the AVE, which means it will be diagonal. To find the correlation of each variable, we need to find it using the latent variable that is here in a PLS algorithm. Therefore, we don't have to conduct the other model collinearity since the model here is a refractive model. After the outer model test, we need to conduct the inner model test, which is the inner collinearity. First, we need to go to PLS algorithm, go to collinearity statistics, directly go to inner IVF. If the IVF is less than 5, means that there is no multicollinearity. In this case, all of my variables are less than 5, so there is no multicollinearity. Next, we have to analyze the direct and indirect effect. First, we need to go to bootstrapping and all of the results will appear there. It can be seen here that there is the original sample, standard deviation, sample mean, t-statistics, and p-value. The relationship will be significant if the p-value is less than 0.05, and it can be seen here that financial self-efficacy to financial well-being and procrastination to financial well-being is not significant. Since both of my direct effects are not significant, therefore there is no mediation occurring using this model. Next, we need to find the coefficient of determination, which is the R-square. First, we need to go back to the PLS algorithm. It can be seen here from the data that the R-square is 31.1% for financial well-being and 48.6% for procrastination. After R-square, we still need to find the F-square. Still in the PLS algorithm, we need to click F-square, and from this data, we can see that most of the variables are a small effect since it is still in the range of 0.02 to 0.1499. The last one is Q-square. So first, let's go back to the drawing pad, press calculate, and click blindfolding. The result will show up like this. It can be seen that my data is small effect since it's still in the range of 0.02 to 0.2499. From this analysis, we can conclude that financial literacy to financial well-being, financial literacy to procrastination, and financial self-efficacy to procrastination is significant. However, financial self-efficacy to financial well-being and procrastination to financial well-being is not significant. So that is all from me. Goodbye and have a nice day.